Welcome to this series in which we'll be looking at calculus. Calculus is an interesting topic in mathematics. It's a very simple topic actually if you just know the principles that are getting used. I'll run over the basics that you need to know in this video. The first thing you need to know is differentiation. So differentiation is a process where we are working on a certain function. So y is equal to a certain function f of x. And then we usually apply the power rule. So there will be kind of a lot of terminologies used in differentiation, but once you just get to know them, it will be very easy. Most of the terms are going to be algebraic terms. For example, you have x squared, you can have x to the power 5. You might even have numbers before these, constants, coefficients, terms like this. Common terms that you see are some that will be rational terms like this. Usually, whenever you see this kind of term, 1 over something, it might even be maybe 4 over x to the power 6. Whenever you see this, remember your laws of indices. Remember that 1 over x is equal to x to the power negative 1. This will be a very important concept that we'll be using when it comes to differentiation. The same as integration. When you see rational kind of function here, we have 1 over that, or maybe 4 over that. Remember, just make that x that's in the denominator have that negative power, just like we do for indices. Now, when we're differentiating, I talked about the power rule. What is it? Well, it just states that if we have any of these here, notice we have x squared, x to the power 5, and these other terms. So I'll write a general form. So if we have a, which is a certain number in front of this in front of the x squared there, we have a 1. Even here we have a 1. You can also say we have, there the 1 is showed properly. So the number in front there is our a. And then we have x. Usually your functions are going to be in terms of x. They are going to be taking x as an input. Then we'll have a power which will be symbolized as n. So if y is equal to ax to the power n, to find the derivative, just like I said, there'll be a lot of terminologies, but I'm hoping you've already learned that. So I'll just be assuming you know all these terminologies. So the derivative is just the function you have after you do differentiation. So if we have y, our derivative, which will be the function after we've done differentiation, will be called dy dx. That you should know. Apart from being called dy dx, you might also hear it being called y prime. It might also be called f prime of x. So these are different ways in which you can represent differentiation. Whenever you see dy dx, they mean the function of y has been differentiated. Now, how do we go about it? So here I'm going to show you the general formula, which is known as the power rule usually. So dy dx, which is differentiating this, is equal to, you multiply. So let me just write something quick that will help you. So we multiply, and then we're going to subtract. So we multiply a and n. Then to the power of x here, we're going to subtract a 1. Just that simple thing. So if you can remember this formula here, we can differentiate all these terms we had at the top. So we multiply this coefficient a, and we also this coefficient a with n, then we get this part here. So this is the multiplication. These two here give us an, and then to this power that we had, we're going to subtract 1. Just as simple as that. So let's kind of work with this 8x to the power 7 and see what it's going to give us. So if our function is 8x to the power 7, if we want to find the derivative, or if we want to differentiate it, we'll say that dy dx is equal to, we multiply this number and the power, so 8 multiplied by 7, then x, 7 minus 1. We simplify this, we're going to have, what's 8 times 7? That should be 54. And 7 minus 1 is 6. So the derivative of this function y is dy dx, which is found using the power rule here, and our final answer is that. We can do the same for these. Let's work with this last one, 4x, 4 divided by x to the 6. So we have the function y is equal to 4 divided by x to the power 6, and then we want to find the derivative dy dx. So remember I said whenever we have the x in the denominator, we want to use our laws of indices. When x is in the bottom, we can raise it to the top like that, and then add a negative, and then put a negative in our power. So we're going to be using the power rule even here. So if we use the power rule, this is a, just to help you, we have a and we have n like that. And now if we multiply a and n, it's the same as 4 multiplied by negative 6, then x, negative 6, negative 1. Here be careful when you have a negative power, notice that the power there is going to become smaller, and don't make the mistake of saying the answer is negative 5, please. So working this out, dy dx is going to give us that there is 24, to be specific, negative 24, x to the power negative 7. So this is how differentiation is done. Very simple. Usually you just be asked to perform differentiation once, but always remember that you can differentiate a certain function more than once, and we can show that very nicely in calculus. When you differentiate more than once, what happens is, for example, let's say we're differentiating y is equal to 8x to the power 7. If we differentiate it, remember we said it's going to be dy dx, right? And then what are we going to work with? 8 times 7 there, which will give us 54. And then we reduce the power by 1, 7 minus 1. This here, if you want, you can't write. To just be fast, you can just do 7 minus 1 in your head and get 6. So this is dy dx. If we differentiate this function again, we're going to have d2y dx squared, and then we do the same, 54 by 6. What's that? Just give me a second to do it. So that should give us 324, and then we reduce our power by 1 again, so we have 5. So the key concept here when differentiating is what? You multiply, then you subtract. Now let's look at integration, which is another very important process. So I want you to remember that we multiplied, then we subtracted. Integration is the reverse process of differentiation. And I'm going to highlight something that can help you stop getting confused sometimes. It might be helpful for you, it might not, but I think it will be. So we had a couple of functions previously, right? I think I can remember the function y is equal to 8x to the power 7. And let's also work with y is equal to, we worked with 4 over x to the power 6, right? So let's work with these two functions here. If we differentiate, which are now an x part, dy dx is going to be equal to 54x to the power 6. This will be our answer. And then for the second one here, dy dx is going to be equal to, notice we're going to change this into the form that looks like this. Then we apply our power rule. Negative 6 times 4 gives us negative 24. We subtract 1 from negative 6, and we're going to have negative 7. Here it's a very common mistake when you have the negative power that someone is going to add instead of subtracting. So be careful there. Now, this process here that we have done is what we're terming as differentiation. Now, integration is actually the reverse process. So we want to come from this 54 and go back like that. This looks interesting. Remember, I highlighted something that was kind of looking not so important. Here is it. Remember, we multiplied, then we subtracted. What did we multiply? I think we multiplied a and n, right? All right. And then we subtracted what? We subtracted 1 from the power. So what if we did these processes in reverse? Okay, notice here, when I multiply, I subtract. So the reverse, imagine this is like, this is your bedroom, and then you go into the kitchen. If you want to go back to your bedroom, you first move out of the kitchen, then get into your bedroom. So the reverse process will be something like this, right? Okay, so the forward is differentiation, which I'll just say to be diff, and then the reverse process is integration. Now, we're not reversing using these same operations. What actually happens is this. We're going to add. Remember what we added? So in integration, we're going to add, then we're going to divide. Notice how this is an interesting way of thinking of differentiation and integration. So for differentiation, we multiply, then we subtract. While for integration, we go in the reverse direction of these operations. But in addition to moving from subtraction to multiplication, we actually use the inverse operations. Remember, addition is kind of the inverse of, additive inverse of subtractive you see what I mean, eh? Addition and subtraction are actually kind of just opposites of each other, to put in simpler terms, while multiplication and division are opposites of each other. So when we go backwards, we also need to change the signs we're working with. So let's try this simple thing that we've noticed here on our functions. Okay, so remember we have these functions here, 54 x to the power 6 and negative 24 x to the power negative 7. Let's try what we just said. So we're going to add, then divide. One key thing here you need to remember is that multiplication and division is going to be like working with our coefficients, while addition and subtraction is going to be working with our powers. So let's look at this 54 here. We have this 54 and it's x is raised to the power 6. Remember I said we're going to add. What are we going to add with? We're going to add with 1, just like we did. So we have the 54 x 6 plus 1, right? Now the next thing is we need to divide. Now how do we divide for us to get back to the 8? Well, I think let's try dividing this by 6 plus 1 and then seeing what we get. So if we simplify this, 54 x to the power 7, I think we have our previous power x to the 7. and then 7 there. And actually, if you see 54 divided by 7 actually gives us 8, and therefore we've gotten back. Cool, right? Now, there's one problem here. The problem is this. When we're integrating and differentiating multiple terms, right? We will get into a certain fix that I'm going to explain very soon. So notice up to now we have just differentiated and integrated one single term. We didn't do a case where we had a lot of algebraic terms that we're working with. Now let's see what happens if we actually do that. Now, just before we kind of go into those details, what I would like you to know is how we symbolize integration. This is something you encounter. Remember, when we see dy dx, it just simply means we have differentiated, right? Now, usually we still have a function. Let's say we have y is equal to f of x, which we want to integrate. The symbol for integration is this kind of elongated S. After further studies, obviously you get to know why they use that, but right now just remember this is the symbol for integration. Whenever you see that, they're telling you to integrate. After that, this function f of x is going to be put right after here, and then after this we're going to have dx. This here simply tells us the variable we're differentiating with respect to. Okay, the variable we are differentiating with respect to. So in questions, as you see when we do them, you're going to notice that we're going to have some where they don't give us all these symbols. They just tell us integrate this certain function with respect to x. So that with respect to x is what this dx means. It means the function here differentiated with respect to x. Now, we know of this kind of simple things. Now let's try using this notation. We have 54 x to the power 6. We just did it. Now let's actually write it using the correct notation. So usually the question might just come like this: 54 x to the power 6, then dx. This is telling us integrate 54x to the power 6 with respect to x. So in our solution, we're going to just do what we did earlier. So we'll say 54x. Remember, we said we're going to add. So 6 plus 1 divided by the new power. So it's just like you add here, then divide by whatever expression is there. Once you do this a couple of times, it will just become very easy. So we have 8x to the power 7. Now, whenever we do this kind of integration where there are no numbers here, usually you have a number here and the number there, I meaning initial and the final there. If there's nothing like that, there's no initial, there's no final, we're going to add a plus c here. This is called the constant of integration. I'll very soon go into what that means. Okay, so this is going to be our answer if our question just comes like this. Okay, simple, right? Now let's look at how we can integrate the other function that we have here. The other function we have here is this one here. We have dy dx, and now we want to get back to the earlier function we had. So the question would simply be integrate 24x to the power negative 7 with respect to x. This is what this symbol notation means. Next, we just do what we did. If you can remember, it's addition, then division. So we have our negative 24x, negative 7. We're going to add, and then the best thing is just copying what's in the power there. So negative 7, 1, and then we simplify. So if we simplify this, you're going to notice that at the bottom here, we're going to have 8 No, not 8. Negative 7 plus 1 is actually negative 6. And so we're going to have negative 24 x negative what? 6. And we're going to have what? Negative 8? No, that's a common mistake. Watch out for that. So at the bottom, we're going to have negative 6. And if we simplify this further, what are we going to have? Notice how we get back to our original answer. Again, here we're going to put the plus c there because we don't have any numbers there. Great, right? This is how integration, differentiation is done. This is the basic concepts that you need to understand. Now, usually the questions are going to come with multiple terms. You're not only going to be integrating one term and things like that. Now, with this information, I think we can start looking at some questions. As we're doing them, I'll be highlighting important things that we need to remember. The first question here is a question 13B from the GCE Paper 1 2020. As you can see, this is a very, very simple question. What we've covered so far is going to help us find dy dx. Given that y is equal to 2x3 minus 4 over x squared, find dy dx. Like I said, when you just see that, remember they're asking you to differentiate. And because there are no nice fancy numbers written with these d's and y's, we know that we're just differentiating once. So the first thing you are supposed to do in this question is just rewrite this function. Just make it a practice to write the function. So this is what we have. Now, something cool about differentiation and integration is that when two terms are separated by addition or subtraction, you can differentiate each of these separately and then combine your answers. So what that means is the answer dy dx is equal to this here differentiated. So if we look at that, remember we said for differentiation you're going to multiply, then after you multiply you're going to subtract. So 2 by 3 gives us 6, 3 minus 1 gives us 2. That sign there, let's just bring it down and then let's work with this. Notice we've put the negative there, so it's just a good thing that you introduce a bracket there. 4 multiplied by the negative 2, then x negative 2 minus 1. I've done this here on purpose so that you can just see the math. Dy dx is going to be equal to what? 6x squared. Notice there's a negative and a negative there, so it becomes positive 8x to the power negative 3. If you want to simplify your answer further, you can take it back to the form that you are given it. So x squared plus 8 divided by x to the third. Simple, right? This is our final answer. Notice nothing is special about this question and you get your marks for it. Let's go to a different one. The next question is 2022 School Certificate Paper 1, and if you have that examination paper, you find this question on question 22A. Given that y is equal to 2x squared minus 4x plus 3, find dy dx. Nice. A good thing is just copying down the question. X 4x plus 3. Now we're going to be finding dy dx. Up to now we haven't found any term that is just a number, right? What I mean here is that we have x to the power 0. X to the power 0, we know from algebra, anything raised to the power 0 is going to give us 1. So basically, there's just no x there. Now, how are we going to handle this? Well, what you need to remember is this. when we have this 3 just like that, actually think of it just like I wrote it. 3x to the power 0. Then perform your power rule here. 0 times 3 gives us 0, x, negative 1 like that. Notice this is going to be 0. Meaning, wherever you see a number and you're differentiating, always remember that that number is just going to disappear from the expression. So if we're going to be finding dy dx of this question, it's going to be equal to 2 multiplied by 2, 4, x to the power 2. There we're going to subtract 1. So 2 minus 1 gives us 1. So we just write x like that. Then negative 4x. We're just going to have negative 4. So can you see something here? Whenever you just see an x there, for example, you've got 8x, the 4x that we have, 9x, all these are just going to remain with numbers. So if you differentiate this, usually symbolized like that, d dx of 8x, we're going to have 8 d dx of 4x, just going to have 4, d dx of 9x, we're just going to have 9. So when you perform differentiation on an algebraic term with x to the power 1, it's just going to remain with a number. So those are some tips that are going to help you just do things a bit quicker. So we're done with this question. 3 marks, right? Nice. Let's get to a different one. Another question here. We have y is equal to 4x to the 3 minus 3x squared plus 5x. To find dy dx, we're just going to differentiate each of these algebraic terms separately. So let's differentiate 4x to the power 3. The 4 multiplied by the 3 gives us 12. The power minus 1 gives us 2. Notice we have a negative. We write that negative. Then we differentiate. 3 multiplied by 6. 3 multiplied by 2 is going to give us 6. And then 2 minus 1, x. The 5x, we're just going to have 5, just like we did in the previous solution. Done, right? Very simple. We have worked with differentiation. Now let's switch to integration. Here we've been asked to find the integral of 3x to the power 2 plus 8x minus 5 with respect to x. Now, one thing we notice here is that we've got no numbers with this symbol for integration, which means we're working with an indefinite integral. So what we're working with here is called an indefinite integral. Indefinite integral. Now remember I said that when we don't have numbers with this sign here, we're going to add a plus c. Let me just show you a quick reason why, so that you understand why we're adding that plus c. Finding this solution here is not a big deal, but you understanding why we're going to add that plus c is very, very important. Let's say you have the function 4x squared. Let's say this is f of x. And say I have added 2. And let's say I have another function g of x, which is equal to, let's say 3, no, not negative, but let me just put 3 there. So 3, and then I have 7. But then let's say this function here is, let's say we have h of x, which is the same as this, but They just differ by maybe 3. Maybe this is 5, like that. And then maybe I have p of x, the same here, which is 3 over x to the power 3 plus 10, let's say. Now, let's try differentiating these here. I'm going to use a different kind of notation here so that, we don't get confused. Remember I said that dy dx can be written as f dash of x, right? So just to show that we're working with different functions here, I'm going to use that notation. So if we differentiating f of x, we're going to say f dash x. If we differentiate h of x, we're going to say h dash x. Okay, don't confuse that notation with inverse. I think that's why they don't use it, mostly for syllabus D. But let's use that kind of notation. It will be easier. So f single dash of x is going to be 8x, right? Let's do the differentiation of h of x. Let's go with g dash of that. So the best thing is we write this. It's going to be 3x to the power negative 1. And then if we work with that, it's going to give us negative 9 multiplied by x to the power negative 4. We do it for p there. And even for the other one, actually, we're going to have the same. Do you notice something here? Of course you do. The answer for the derivative of f of x and h of x give 8x. The same applies to g of x and p of x. We're having the same derivatives, but the numbers that we've added are different. So basically, we're adding that plus c because they are quite different kinds of functions. When we integrate, that can be differentiated to give us the function we're integrating. Well, that was a bit confusing, right? What I mean is this. If we integrate this, we're taking f prime of x back to f of x, right? Now, there are many types of functions that we can differentiate. There are many kinds of f of x which we can move into that direction. As long as we just change the number there, we can have 4x squared plus 1, 4x squared plus 2, 4x squared plus 5. There will be different kinds of numbers that we can put here that are still going to give us 8x. Just like I've showed you here, when we put this 5, the answer is still 8x. Therefore, we add a plus c to show that there are different numbers that can be added to this solution for it to be correct. Now, to get over this is why we have definite integrals. Later we'll have an example about them, and then we're going to also talk about them. So remember, why we are adding the plus c is because when we move from a certain function and we integrate, let's just do that quickly here. Let's say we are integrating 8x. So if we integrate 8x with respect to x, what we're going to have is 8x 1 plus 1 divided by 1 plus 1, which is going to give us 4x squared. But now, the dilemma here is this. Look at our 4x squared. Both of these functions are 8x, right? So if we integrate any of them, we're going to have 4x squared. But we can see that f prime of x actually came from 4x squared plus 2. While this other 8x came from h of x, which was 4x squared plus 5. So there are different numbers that we can add to this answer and it will still be correct. This is why we're adding this plus c, which is known as the constant of integration. I hope that simple explanation was kind of enough for you to understand why we're adding that plus c. There are many more explanations that we can give, graphical ones, and you can understand this even better, but usually for syllabus D, that's just enough. So whenever we don't have numbers there, we're going to add this plus c for the reasons I've just shown. Notice if you integrate these two functions, g prime of x and p prime of x, you're going to get back to that, and you're going to notice that you're not going to be able to get back this 10 and that 7. Furthermore, you should understand why we can't get that back, because that x was to the power 0. Remember, I talked of an x being to the power 0 and we have this here, right? So it's very difficult to get that 0 back. But with some conditions, yeah, we can find that 7. Now, let's get working with this question that we have right here. The question that came in 2019 paper 1, the school certificate exam. It was question 16A. And let's try integrating that. All right. The first thing we do is just copy our question. 3x squared plus 8x minus 5. And we're integrating this with respect to dx. One thing that you would do to make this sometimes easier for you, though after some time it's not really making things easier, it's just a longer way, eating up your time in the exam, is you write these terms separately. We only do this because of what I said earlier. When we have addition and subtraction, separating algebraic terms, we can do the process of differentiation or integration separately, then combine our answer for all those terms that we integrated or differentiated, and then express it as our answer. So here we can say this is equal to 3x squared plus, we need a dx here to show the term, the variable with which we're integrating with respect to. We have 8x dx minus 5, the integral of 5 dx. Nice. And we can work with this. So let's do it for the first one there. The first one here is going to be 3x 2 plus 1 divided by 2 plus 1, and the next one there is going to be 8x 1 plus 1 divided by 1 plus 1 minus 5x, we've got a 0 plus 1 and 0 plus 1. Here we're going to have a plus c. If you want this plus c, you can just be written at the end of your answer. So let's simplify this. Simplifying, we have 3x to the power 3 divided by 3. You can see that this 3 and that 3 are going to cancel. We're going to be left with a 1. Here we have 8x squared divided by 2. You can simplify this further. We have a 4. And we're left with a 1 in the denominator. And for our last term, we just have 5x. So the solution for our question, which was 3x squared plus 8x minus 5 dx, is equal to x to the power 3 plus 4x to the power 2 minus 5x. And remember, because we don't have any limits here, those numbers that we put there are called limits. Now you know them. We're going to add a plus c. This plus c indicates that if we put any number there, our solution is going to be correct. I've explained that, and I'm sure you won't have any problems with understanding when we're putting the plus C. So this here is our solution for this question. Easy peasy squeezy. Very easy, right? In the next question, we've been asked to find the integral of 3x to the power 3 divided by 2 minus 5x plus 1 over x squared with respect to x. The first thing you do is just convert this to mathematical notation. Just a keynote, this notation we're using here was found by Leibniz. Yeah. If you want to know more about him, and you can check multiple videos on YouTube, and you'll find interesting stories about how this notation was found. Yeah, I think his name is spelled as L-E, and some might just write it like that, or you might find it as L-I-B-N, I think, yeah, with a T. Yeah, you can search that on YouTube and put notation, and you get a whole lot of deal. But do this after you study, of course. Yeah, that won't be examinable. So yeah, let's concentrate on what we're doing here. So we have 3x to the power 3. I think I can write that better. It looks a bit confusing. We have 3, a big 3, a power 3 like that, and then a 2 minus 5x. And then here, remember, what we did was bring this x to the numerator, and using our algebraic skills that we've learned, we can rewrite this expression like this for us to be able to integrate it easier. And we just perform what we did. This time I'm not going to be doing all the writing and the like I said. You can write extra to prevent some mistakes, but after you do this a couple of times, I think you'll be comfortable. So we have the 3 x 3 plus 1, and then I divide. Remember, I've got a 2 there, then I'm going to multiply by 3 plus 1. Just copy the power of x in the numerator and multiply it by the denominator. Then here I've got 5x 1 plus 1 over 1 plus 1 plus, got x negative 2 plus 1 divided by negative 2 plus 1, and I can add my plus c at the end. Let me simplify first. So I have 3x to the power 4, then this is a 2, this is going to simplify to 4, so I have 8 in the denominator, and then 5x to the power 2 over 2. Notice here I've got a plus, but that minus is going to change things a little. Negative 2 plus 1, negative 1. And I'm also going to have negative 1. So this is my final answer. Now let me just express it properly. So we have the integral of 3x. We had 3 over 2 x to the power 3 minus 5x. Then we had plus 1 over x squared dx. And this has given us 3 over 8 x to the power 4 minus 5 over 2, like that. Then we have a negative 1 over x. And remember, we're supposed to put a plus c here. We're supposed to add plus c. So let me just create some space for that. And here's our solution. Also easy, right? So what I'm trying to tell you is calculus in your exam is a free question given to you. maybe until we get to the application, and maybe it might be tricky for some people to understand that, but for now, everything we're doing is very, very simple. This is our next question. Again, you see, we're just asked to find the integral of 6x squared minus 2x plus 7 with respect to x. So we can just write that down. 6x squared minus 2x plus 7 with respect to x. Then we start finding our solution. The first term here is 6x squared. We integrate that, very simple, plus 1 minus 2x, 1 plus 1, plus 7x, 0 plus 1 over 0 plus 1, and we have 6x to the power 3 over 3 minus 2x to the power 2 divided by 2 plus 7x, and we can add our plus c. What I would like you to do for now is that the next question, or even for this one, I hope you pause the video and then try to work it out and then see if you really got this. In fact, here we can simplify even further. Our final solution can be 2x to the power 3 minus x squared plus 7x, then our constant of integration. This is our final solution. We have another question. Please pause the video and try this question on your own, then try to see how we work it out. Hope you're back. So we're going to do the same thing as we just did for the others. So we have 4x plus 3 over x squared, and we're integrating this with respect to x. Now let's work this question out. This is going to be equal to 10x 4 plus 1 divided by 4 plus 1 minus 4x 1 plus 1 divided by 1 plus 1 plus 3x negative 2 plus 1 negative 2 plus 1. I hope that never confused you. When we simplify, we're going to have 10x to the power 5 divided by 5 minus 4x to the power 2 divided by 2 minus 3x to the power negative 1 divided by 1. Already gotten rid of that negative. I hope that also never confused you. And actually, we could write this in the form that it was given to us. We would say 3 over x, then plus c. This is going to be our final solution. But wait, think we can simplify, right? Yes. So always remember to simplify your expressions. There we've got 2x to the power 5 minus 2x to the power 2 minus 3 over x plus c. And now this is our final solution. Remember, whenever you're writing an exam, in mathematics specifically, always make sure you simplify your answers. You never know where the extra marks come from. You might have answered it up to this stage, but your examiner actually wants it up to this one. So make sure you do the right thing. Up to now, we have covered quite basic concepts of differentiation and integration. I'm sure by now you understand them. You know why we do certain things. But now let's talk about definite integrals. When we say we're working with a definite integral, what we basically mean is this symbol, which means integration, has a number at the bottom here and one at the top. Always remember that the one here at the bottom is the one that is your initial value, and the one at the top is your final value. Usually, definite integrals represent areas under a graph, but we won't talk about that so much. What I want you to understand is when we have a function, for example, f of x, and we're integrating it with respect to x, the answer we expect by integrating f of x is the function which was maybe some time back differentiated, right? Let's say that function that was differentiated is y is equal to capital F of x. After we perform the process of integration, right? So what I mean is we have y is equal to f of x, then dy dx is equal to f of x. When we perform integration that is definite or defined using an initial and a final value, we're going to get from this f of x back to the capital F of x. This function here is usually, you might hear it being referred to as the primitive function, or just remember that it was that function that was earlier differentiated to have dy dx. So, forgetting about the limits for just some seconds, we know that we can integrate the inside function. And when we integrate it, we're going to be taken back to f of x. So, integrating that, we're going to have f of x, and then what you might be thinking is we're going to do what? Add plus c. Yes, you're not so wrong, but we forget about that plus c, mainly because we have the initial and the final values. So what we're going to do, instead of adding that plus c, we're going to evaluate this integral. Usually you might see this being symbolized by a vertical bar like that, or some people might tend to write it like this, and then they're going to put their initial value here and their final value. So what that means is, in this function, after we integrate, where there's this x, we're going to put f, then we're going to subtract f of I. And this is what is going to be our final solution. Here I've used kind of symbols in mathematics to explain what we're going to do, but let's try looking at an example. Even before we get into these exam questions and stuff, let's just try simple examples like we did for integration and differentiation at the beginning. We'll just start with one term and then generalize it to the questions that come in the exam. Let's say we have the function y is equal to x. Remember I talked of integration, specifically integration using definite integrals being area, right? So it's like saying whenever we have a definite integral, what we're talking about, it is implying that we're talking about area. Just to stress this concept, the example I'm going to use is a function that you know. Let's say we've got y is equal to x. If we were to graph this function, what we're going to expect is at 1, we'll have a point like that, and if we continue going up, we'll have something like that. Now if we join these lines like that, maybe that can be made a little bit bigger, but yeah, okay, that's, I hope you can see that line. Is that one visible? Okay, anyway, let's just work with that. So we have those points there, and this here is equal to that, right? Y is equal to x, that's the line. Now, if truly integration using a definite integral is finding the area, you can see that this is a triangle. The base is 1 and the height is 1. Therefore, the area we expect after we use definite integrals is half BH. So we're expecting that the area that is shaded there, that's what the AS means, the shaded area, is equal to half square units, right? Or simply the shaded area is equal to 0.5 square units. If this was meters and this was meters, meaning the shaded area is going to be 0.5 like that square meters, right? So if we get this answer using definite integrals, then truly we have proved that kind of, if we use a definite integral, we're just simply finding the area under a particular curve. So let's try that. Y is equal to x, and so we're going to be finding the integral from 0 to 1. Remember, that was the base we took. And then our function there of y is just x. Then we're going to be integrating with respect to dx. When integrating this, like I said, just forget about those limits and focus on the function there. We've got x, so it's going to be x1 plus 1 over 1 plus 1. Then we can symbolize our limits like that, 0, 1. We can even use another square bracket like that, which means we're going to be working with x squared over 2 and we have 1 and 0 like that, right? So if we simplify this, remember I said we get this number on top, we plug it in where we've got x, so this is the same as 1 squared over 2 minus 0 squared over 2. Notice if we simplify this that we have here, we're going to have half. So the answer to our definite integral is half, and if required you can put that because it symbolizes the area, but yeah, maybe they might be a little bit lenient, but yeah, this is our answer. Notice that we have the same answer that we just did here using geometry. This is the power of calculus when you go into it in depth. Now let's look at some exam questions. We know this basic understanding and we can appreciate why we're being taught about definite integrals. Here we have a question. We've been asked to evaluate this integral here. So we copy it. We have 3x squared plus 4x. So how do we read this? You start with the function, so you say evaluate the integral of 3x squared plus 4x from 1 to 3 with respect to x. The integral of the function from 1 to 3 with respect to x. That's how you just read it. Now, how are we going to work this out? Very simple, like I said. We're going to integrate this just like we've been doing. So we've got 3x squared divided by, so we add the 1 there, 2 plus 1, then 4x1 plus 1 divided by 1 plus 1, and then because this is a definite integral, this here is a definite integral, we're going to use these square brackets to our advantage. Then we simplify what's inside. There we've got 3x to the power 3 divided by 3. So I can see that is going to simplify to x to the power 3. If you want, you can write that just to prevent any errors due to mental math. And then 4x squared divided by 2. You can see that 3 is going to cancel out with that 3. The 2 here can go into 4 2 times. We're left with the 1 in the denominator. So if you keep simplifying as you are writing, you just have to write these parts over and over again, which might get some of your time. So we have x to the 3 and 2 multiplied by x to the 2. Then we evaluate this integral from 1 to 3. Like I said, when evaluating this integral, we're going to start by plugging this 3 into this function. So we have 3. Mostly just get used to putting brackets there in case you have a negative. Plus 2. Like that. Then from this, we're going to be subtracting the function where we've replaced 1 in place of x. So we're going to have 1 to the power 3 plus 2, 1 to the power 2. Working this out, 3 to the power 3 should be 27. 3 times 3 is 9. 9 times 3 is 27. Then we work with this. 2 multiplied by 9, which is going to give us, can do that, or actually just perform everything at once. Know that that's just 18 minus 1. Remember, this minus is affecting everything here. So it's a common mistake for people to just make this minus affect this. So right here, it's a good practice that you put this like that. I think I can write this a bit even better for you to understand it. Instead of writing it like this, let me just write it in a different way so that you can see what I'm talking about. Common mistake here. So you do that correctly, replace correctly like that. Then you make a mistake of just doing this. Then you say 1 to the power 3 plus 2, 1 to the power 2, right? Now, what happens? Since you've just put a minus here, you think, yeah, everything is alright. Actually, you haven't made much of a mistake. You've integrated very well. But now when replacing your values, this negative here, the best way to treat it is do this. Then you won't get your answer wrong. Working this out, the 27 there, 3 times 3, 9, 9 times 2, 18, then minus. You can work with what's in the brackets. This is 1 and that's 2, so we're going to have minus 3. And then you calculate this. 18 minus 3, however you do it, you're going to get 18 minus 3, which is 15. 27 plus 15 is going to be 42. You can arguably put this here, but yeah, mostly you won't really be penalized, I think, for not putting the units there, but yeah, it's a good practice that you put it. So we're done with this question, and this is how you could simply handle it. Key things you should take note of is that this is a definite integral because we have limits here. 1 is the lower limit and 3 is the upper limit. And we can write the question like that. And this is how we progress. We integrate the inside function, just like we've been doing all along. And then notice something when we're working with definite integrals is that we don't have a plus c. We don't have a plus c because we have these numbers here, which are going to give us no reason of putting a plus c. After we do that, now we come to the part where we are evaluating. This is the evaluation part here. So we've integrated the inside function, now we need to evaluate. We first replace the upper limit into the function here which we have integrated. The 3 there, then I emphasized here where we should take a lot of care when we are subtracting. And then working out, we have our solution. Here's another question that we're working with. We've been asked to evaluate this integral of 1 minus 4x plus 3x squared dx. And we are evaluating it from -1 up to 1. That one didn't look like a very good one. Yeah, that looks like a 1. So we're going to start working this out by first integrating this function, then applying the limits to evaluate the integral. When you have 1 there, it's going to give us x. I think you know that now. Whenever you have a number, it's x 0 plus 1 divided by 0 plus 1, which just simply means x to the power 1 divided by 1. So whenever you see a 1, just know that that 1 is going to become an x. Another way of seeing this is when you just see this. Whenever you see this, it means here we've got a 1. Therefore, the integral of this is going to be x plus c. Notice I've got no limits, so I'll have to put a plus c there. Let's continue with our question here. We can forget about that. We don't need to be writing everything. Now I think you are a bit comfortable. We've got a 1 there, so our new power is going to be 1 plus 1, which is 2 divided by 2, plus 3x to the power 2 plus 1. 2 plus 1 is 3. And we're going to divide by that new power. Remember, because this is a definite integral, we should never forget working with our limits like that. Now, we see if we can simplify anything. Of course we can. 2x squared plus we have x3 there. Now we plug in our limits. We're going to start with 1. So we have 1 plugged in. 1 squared is just 1. So I think, yeah, but just to show your work, you can do that. You might be penalized also for not showing your work. So make sure you're not skipping steps that are very important. Then we're now plugging in the -1. Remember, before plugging in this lower limit, make sure you write -1, open some brackets, then start plugging in your numbers. We have -1 there, 2, -1 squared, plus -1 to the power 3. And now let's simplify a bit. We have 1 minus 2 plus 1. So this one and this one give us a 2. Got a 0 for this first part. And we work out what's in the brackets. We've got a -1 there. Here it's better you just take your time and evaluate it very carefully. -1 times -1 is 1. So we have -2. Then here we have -1 multiplied by -1 multiplied by -1, which is going to give us -1. Therefore, our solution here is going to be the sum of these, which is positive 4. You can add this or not add it, but yeah, I'm just more comfortable with adding it there because we know that a definite integral always gives us an area. All right, let's look at another question. We have an integral here which is simple to evaluate. Pause the video, try it out, and then compare the solutions. Evaluating what's inside, we have 4x, then 3x to the power 3 divided by 3. I'm sure you know how to do that by now. We indicate our limits here, and then we insert our limits into the function. We start with our top there, so the 2 goes there. Notice this here can be simplified, so we're just going to have x to the power 3. Then we subtract off our lower limit, remember -1 like I said. Then we have a 4, -3 minus x to the power 3. We have 8, 4, -1. We work what's inside the brackets here. We have a -12, negative and negative there. Notice this is to the power 3, so it's -3 multiplied by itself 3 times. We're going to have -27. That -27 multiplied by this negative is going to give us a positive, and working with this, here we're going to have a 4 minus 27 minus 2. You can do this quickly. I'm sure you know how to do this. 7 minus 2 gives us 5. 2 minus 1 gives us 1. So we're left with 15. Now notice we have a negative answer, which is going to be -11. This is actually correct. In such cases, don't really like putting the unit squared here because we can't have a negative. We can have a negative area, but for now, we can't imagine us having a negative amount of area. So we can forget about that and just write it as -11. Actually, here I noticed something that's not so right. Notice here, we've got a 3 instead of a 2, which makes this an 8. So we don't have a 4 there. We have an 8, then which makes this part here a 0, and which makes our answer being -15. And yeah, that will be our solution. Here we have another question. We're evaluating an integral from -1 to 4 for the function 2 plus 2x plus 6x squared dx. Working with the inside function, we're going to have 2x plus 2x squared over 2. Notice here it's 1 plus 1. So 1 plus 1 gives us a 2. Then the new power is what we divide by. And then we have 6x3 over 3. Notice one thing they do for these questions. I think this should be a paper 1 question. No, paper 2. Yeah, most of our questions that we've answered, I don't know if you've noticed, most of them are simplifying down to an easier function. Yes, to make things a bit easier for you to work with. When you go into real calculus, okay, yeah, this is real calculus, but yeah, when you start applying calculus, you find most of the functions won't be as easy as they are seeming right now. From -1 to 4, evaluating this means replacing our values of x, starting with the one for the final. So 2, 4 plus 4 squared plus 2, 4. This time I'm seeing it. There's a 3 there, not a 2. -1. This -1 is not the one there. It's just showing that we're subtracting off the value of the answer when we plug in the lower limit. So we have a 2, -1 like that, plus -1 squared plus 2, -1 to the power 3. Yeah, I think that's a bit more visible. Okay, now here we have 8, 16, 4 to the power 3. That should give us 16 times 4, which is 64. 64 by 2 gives us 128. Then working with what's inside the brackets, we have -2, a +1. Here we have a -2. So -2 minus 2, that gives us -4. -4 plus 1 -3. -3 multiplied by -1 should give us a +3. So what we're working with is 8 plus 16 plus 128 plus 3. And if we do the mathematics here, we should have our answer. Let's see. What is that going to give us? 8 plus 16 plus 128 plus 3. That gives us 155. Since this is positive, yeah, I'm tempted to just write square units. But yeah, you can leave your answer just like that. And you have evaluated the integral. Well, now we're going to be talking about application of everything we've learned up to now. We've differentiated, we've integrated using indefinite and definite integrals. We understand what both these methods are and what they are talking about. Now, mostly in your syllabus questions, you also be asked to apply calculus. They're trying to see if you really understand the basic concepts of calculus and see if you appreciate them. Now, before we just get into that, let's just talk about what we've just looked at, indefinite integrals. Let's get back to our function here, which was, okay, let's use x squared plus 6. And this is the function we want to find the integral for. It's a definite integral. Now, in this example, I just want you to appreciate why we're not putting a plus c there. I said we're not because we have these limits, so there's really no need. But what happens if we include the plus c? Notice the integration here is going to be x to the power 3 over 3 plus 6x, and then we can add a plus c like that, then 1, 0. Notice this c does not have an x, so the 1 there is not going to affect it. So if we evaluate this, we're going to have 1 over 3 plus 6 plus c minus 1, 0 there, right? And 0 here. Then we're going to have our plus c. So from here, the only thing we're going to have is a plus c. Now this plus c will be multiplied by that negative, so we're going to have 1 over 3 plus 6 plus c minus c. So notice these c's cancel out. That's the reason why. Now let's talk about application. What are the key things you need to remember when applying calculus? Well, the first and foremost is looking at differentiation. So when we have differentiation, what are we doing? The first thing you need to understand about differentiation is this simple fact. When you have a function, for example, 2x plus 3. This is a linear equation, right? It's in the form y is equal to mx plus c. You agree with me? M here is the gradient. Now, something that is very important to remember in calculus is that when you find the derivative of a function, meaning you find dy dx, the function that you're going to have, in this case it's going to be 2, just a constant, is the gradient function. What that simply means is dy dx is going to give us the gradient at any point on this line. Now think of this. Here we got the first point when x is 1, 0. When x is 1, we expect our graph to go to 5. So this is 4, 5, and that point will be somewhere here. When x is 2, y is supposed to be 7, a point somewhere there. And we can confidently say our graph is going to move something like this. So this is y is equal to 2x plus 3. Now, what dy dx tells us is the gradient at any point. Notice for this function, we don't have any x in our dy dx. And that is actually true. If we compare this with this, if we compare y is equal to 2x plus 3 with the form of this equation, y is equal to mx plus c, truly m is 2. So at any point, let's say x is equal to 1, the gradient is going to be 2. If you find the change in y over that, exactly. So again, if you go to any point, let's say 4, the gradient you're going to be finding, I hope you can remember, gradient is equal to y2 minus y1, x2, x1, like that. Maybe it might be helpful sometimes, but rarely in calculus. In calculus, we'll be usually representing our gradient as a function. And here, this simple concept is going to be taken to all other functions. Let's take a look at how that might change if we just change the function here. Let's say we had the function y is equal to x squared plus 3. Here, what we've learned so far in syllabus DMath, we can't apply this format to this equation. Furthermore, what we see is that the gradient at each point of this function is going to be different. Let's take a look at the plot of this. This here is a curved line. If we were to zoom in, it will look something like this. Now, if our tangent, if we want to find the gradient at a certain point, let's say a point here, we need to make a tangent. If we want to find the gradient at this point, then we need a tangent there. Now, creating a tangent here will we'll be just estimating the gradient at that point. Calculus helps us find the exact value. So if we differentiate this, we're going to have 2x, right? So this function here is termed as the gradient function. What that means is this function here, dy dx, is going to give us the gradient when we plug in the point at which we want to find the gradient. For example, if we want to find the gradient when x is 1, let's say this point here is 1. Remember, we found that 1 was paired with 4. Let's say this point here is 2, and we found that the value of y when x is 2 is 7. So if we want to find the gradient when x is 1, we're just going to bring that 1 and plug it there. The gradient using this formula at the point 1, 4 is going to be 2 multiplied by 1. If you want, you can say m. So m is going to be 2. At the point when we have x equal to 2, we can say that's m1, this is m2. We're going to have our gradient being equal to 4. Notice our gradients are not the same because the gradient is changing when we have a curved path. This looks very, very simple, but notice something. In this diagram I drew here, this line here is the tangent. Therefore, with this simple principle, we can find the equation of this tangent. How, you may ask? Now, notice here, since we are finding the equation of the tangent at 1, 4, we have the values of x1 and y1. Therefore, y is equal to y1. y1 is 4. The gradient m, remember the gradient function dy dx, is equal to 2x. So we'll just get the value of x there, plug it there, and at the point when x is 1, our gradient is 2. So we plug in a 2 where we have the m. Then x1, we put that 1. We simplify this and we have y is equal to 2x minus 2x plus 4, which gives us 2. So the equation of the tangent, this one here, is equal to 2x plus 2. With this concept, we can use more concepts of coordinate geometry. For example, you might be told to find the equation of the normal. So things you need to remember are that the normal and the tangent are at 90 degrees. And because of that, you need to make use of the relation we know that m1, m2 is equal to -1, given that these two lines are at 90 degrees to each other. Let's look at some exam questions that tackle that. In this question, we've been asked to find the equation of the tangent to the curve y is equal to 1 plus 3x minus 3x squared at the point 1, 1. With what I just discussed earlier, I think it won't be very difficult for us to understand what needs to be done. The first thing is we need to find the gradient at the point 1, 1, and then find the equation of the line using that gradient and the point 1, 1. So the first thing here is utilizing calculus. dy dx is going to be equal to 3 minus 6x. This here is our gradient function. At 1, 1, our gradient m is going to be equal to 3 minus 6, then the value of x, which is 1, which is going to give us 3 minus 6, which is equal to minus 3. So this is the gradient at the point 1, 1. And we know how to make an equation with 1 point. So equation of the tangent is not something difficult. We're going to use the formula we just used. Y is equal to y minus y1 is equal to m x minus x1. We know the value of y1 is 1. The gradient was just from finding negative 3, x minus the value of x1, which is that. If we simplify this, we have minus 3x minus multiplied by minus there, we have a positive. We simplify this further, we have y is equal to negative 3x plus 4. So this here is the equation of our tangent. We have a function like that. This function is the one we've been given in the question. Y is equal to 1 plus 3x minus 3x squared. This is the function. Then we have a tangent that is touching at a particular point somewhere here. This point is 1, 1. And we've just found out that our equation of this tangent is y is equal to negative 3x plus 4. Let's look at another question. Here we're going to be finding the equation of the normal to the curve y is equal to x squared minus x plus 4. And we're finding the normal to this curve at the point 1, 6. To find an equation of a line, the normal is a line, we need to use the formula y m x. To be able to do this, we need to find m. That m is equal to dy dx evaluated at the point of contact, which is 1, 6. Now, notice something here. If this is our line, we can have a normal like that, and then this here is going to be our tangent. The angle between these two lines is always 90 degrees. Therefore, the trick in this question is you remembering this simple fact that the tangent and the normal at 90 degrees. Therefore, the gradient you're going to find with this equation is not going to give you the gradient of the normal. It's going to give you the gradient of the tangent. Therefore, you need to remember the relationship between these two lines. m1, m2 is equal to negative 1. If, let's say, this m1 is the tangent, the gradient of the tangent, and m2 is the gradient of the normal, you can make m2 the subject. Then you're going to have m2 is equal to negative 1 over m1. So using these principles, we're going to answer this question and see how it turns out. The first thing is finding the gradient of the tangent. Dy dx is equal to this here differentiated. Differentiating x squared, we have 2x. Differentiating negative x, we have negative 1. And differentiating the constant there, the 4, we have 0. So this is our gradient function. It's going to give us the m of the tangent. Let's say that m is m1. which is equal to 2 at the point 1,6. So x is 1. And if we evaluate this, it's 2 minus 1, which gives us 1. So the gradient at this point of the tangent is 1. If we use this relationship that we know from coordinate geometry, we can easily find that m2 is equal to -1 divided by -1, which gives us, sorry, we had the 1 actually. Here we're supposed to put m1, which is equal to -1 over 1. Therefore, m2, which is the gradient of the normal, is going to be -1. We're going to just do what we did earlier to find the equation of the normal. The equation of the normal is given by y minus y1 is equal to m2 x minus x1. In place of y1, we're going to put the 6. m2, we're going to put the -1 or just from finding. In place of x1, we're going to put 1. Then we simplify y. This 6 crosses over to the right hand side, and we have -x, the negative and the negative, plus, and this becomes positive. Therefore, the equation of our normal is going to be equal to y. If you want, you can write it as 7 minus x. And this is our final solution. You can pause the video and try out this question, and then compare a solution with the one that will be found. After differentiation, this is what you should get. After you plug in the value of x at 1,3, m should give you 4. After you work out the equation of the tangent, I hope this is what you're getting. Y is equal to 4x minus 1. Here's another question, a very interesting one actually. The gradient function of a curve is 3x plus 2. Find the equation of the curve if it passes through the point 0, 2. Interesting, isn't it? Alright, so they're telling us that dy dx is equal to 3x plus 2. Then they're telling us that we need to find the equation of the curve. It's not a tangent this time, it's not a normal, but we want to find the equation of the curve if it's passing through the point 0, 2. So, very important, 0, 2, I'll say that's x and y. Now, remember, earlier in this video, it's quite a long one, but I hope you found time to watch most of it, because if you watch this one, I'm guaranteeing you calculus will be very easy. We said if y is equal to f of x, then dy dx is equal to f of x. Now, remember that the process of integration using a definite integral, remember we said if we use a definite integral with initial and final, there we said if we get this f of x, we integrate it with respect to x, our answer is going to be f of x evaluated from the initial point to the final point. Now, this time, if you look in this question, there's nothing like that. So are we stuck or something? Well, we're not really. What we're going to do here is we're going to integrate this gradient function using an indefinite integral. and that's going to be 3x plus 2 dx. Notice we don't have any limits, so if we work this out, we're going to have 3x to the power 2 over 2 plus 2x plus c. Notice this function here that we have is our f of x, which is dy dx, and then this function on our right side is our f of x. Watch this very clearly. We said that y is equal to f of x, right? Let's try using that. Y is equal to 3x over 2, then that. Then we have plus c, right? Do we have any information about x and y? Of course we do. The information of x and y is 0, 2. Let's try plugging in 0, 2. So at 0, 2, we can find the value of c, in short, is what I'm saying. At 0, 2, we got 2, which is equal to 3. Notice, since we have got a 0, we don't need to worry about everything else. If you want, you can write everything. But what I want you to see is this 3 and that 2 becomes 0, and therefore c is going to be equal to 2. After we find the value of c, we found that constant that always gets lost. Remember, we said we always add this c because we don't know which function gave us. But if we use the values of x and y at a particular point, we can find the function. So the equation of the line is equal to y which is equal to 3x squared over 2 plus 2x. The c we just from finding, it's 2. So this is our final answer. Actually, we don't have a line, we've got a curve. So the equation of the curve is going to be equal to that. We have another question here which I found interesting. We're asked to find the equation of the tangent to the curve y is equal to 2x plus 3 to the power 3 at the point where x is equal to -1. Notice something here. They haven't given us our y value. Remember from what we've been doing, for us to find the equation of the tangent, we're going to use this equation, y minus y1 is equal to mx minus x1. We can find the value of x1, which is that -1. So we have a -1, but we don't have the value of y. That's not a problem because they've given us the equation of the curve. So in place of x, we're going to put y at x is equal to -1 is what we want to find first. So 2 -1 plus 3 to the power 3. Inside here, we're going to have 3 minus 2, which is 1. So we have 3 minus 2 to the power 3, which gives us 1 to the power 3, which is equal to 1. So we have our coordinates. It's -1, 1. Therefore, when we come to use this, we won't suffer much. The next thing we need to sort out is m. We need to find m. How are we going to find m? We need to expand 2x plus 3 to the power 3. Otherwise, we won't be able to integrate that we won't be able to differentiate that very easily. So the gradient m is equal to dy dx. That we know. However, before we even find this m, we need to find the expression that this is equal to. When you do more of differentiation, you'll be able to differentiate this using more methods. Remember, the only method we've been using so far is the power rule. So if we have this, if we differentiate it, it's going to be, you can say an like that. But in this case, if you use this like that, you definitely get this question wrong. So the best way, the easiest way, if you don't want to sweat so much, is just writing this as 2x plus 3 squared 2x plus 3. This is the simplest way you could do it. There are many other ways that you could do this very quickly, but I want this to be just a very simple method that you can easily remember. So we have this here. We can easily work with this part here. 2x plus 3 squared is equal to 2x squared plus 2 multiplied by 2x 3 plus 3 squared. 2x there is going to be 4x squared. We're going to add a 12x and a 9. So this is one of these parts, and now this answer we want to multiply with the 2x plus 3. It's kind of a longer method. Notice how I found the answer of this very quickly. I used what is known as, detailedly, it's known as the binomial theorem, but yeah, you can just think of it basically like a formula. If you have a plus b raised to the power 2, your answer is going to be a squared plus 2ab plus b squared. Notice whenever you're picking a, pick it in brackets. A here is 2x. So I pick the 2x, put it in brackets, then square it. Then the a is the 2x, the b is the 3. Multiply it like that. And then I have my answer. I would do the same actually if I have that. I could do it right from the start. The formula for this one is a to the power 3 plus 3a squared b plus 3a b squared plus b to the power 3. These things here are just some things you can note down that might help you solve this question a bit much faster. But I'm not using this method so intensively. I've only used the first one, a squared plus 2ab plus b squared. This one you must know. This other one for syllabus T, you can do without it. There are not so many things you're going to be expanding that will take much of your time. Okay, so we expanded 2x plus 3 squared. Now this is our answer. Our answer is 4x squared plus 12x plus 9. And now we're going to be multiplying this by 2x plus 3. So the 2x will multiply by everything there. What we're going to have is 2x multiplied by x squared. The 2 and the 4 give us an 8. X squared multiplied by x give us x to the power 3. Here we're going to have 24x squared plus 18x. We do the same with the 3. 3 multiplied by each of the terms there. we're going to have a 12x squared plus a 36x plus a 27. So this function here is the function we have. That's the function of the curve. Of course, I'm sure there's something we can simplify. You can see some squares there, an x and an x. So we surely can simplify this. We can write it as 8 to the power 3. Then this x squared and that x squared added together is going to give us 36 x squared. The 18 and the 36 are going to give us 54 x, and then we add our 27. If you use this formula here, you're going to get directly to this answer. Right now we just need this answer and then get to see how we're going to handle the rest of the question. Okay, now let's find dy dx of this. Remember, this is what y was equal to, so dy dx is going to be equal to differentiating each of these terms one at a time, then combining the solution. 8 by 3 is 24. We reduce the power by 1, becomes a square. 36 by 2, that's 72. We reduce the power by 1, it becomes a 1. And we have 54. So our gradient m is equal to this function, and then we plug in a 1. 72. You see how the 1 simplifies everything? Plus 54. Or was it negative 1? Yeah, x was negative 1. Let's correct this. So we have 24 negative 1, okay, 72 negative 1 plus 54. So our gradient is going to be 24 plus 54 minus 72. This here gives us 78, so I'm sure this will give us a very nice answer. 4 plus 4, 8, 5 plus 2, so 78 minus 2. We can write it here. 8 minus 2 is equal to 6. So this is our gradient. Now, since we have our gradient, we can find the equation of this tangent. Y minus y1 is equal to x minus x1, which means that y minus 1 is equal to 6x minus 1. Remember, x1 was negative 1, and so our final result should be y is equal to 6x. Here we've got a plus, so it's going to be plus 1, which means the equation of our tangent is y is equal to 6x plus 2. Now, we'll be remaining with our last question where we solve some stationary points, and I think with each and every question that we've tackled in this video, you'll be able to write any question or answer any question about calculus tomorrow. Okay, here we've been asked to find the coordinates of the stationary point of the curve y is equal to 2x to the power 3 minus 3x squared minus 12x plus 4. The first thing we need to do is understand what a stationary point is. If you think of the word stationary, it just simply means not changing or in a specific position. For example, you might say a track is stationary and things like that. When we are talking about calculus, stationary means the gradient function is equal to 0. Remember, gradient is the change in y with respect to x. Points where we can possibly have dy dx equal to 0 are this one here and this one here. Basically, what I want you to understand is a stationary point is a point on a curve where dy dx is going to be 0. dy dx symbolizes the gradient, you agree with me, right? So dy dx is the gradient, so m is equal to that. When m is 0, we have a stationary point. Something that's very important when you're talking about stationary points to understand is that a stationary point happens when there's no change in the y-axis. We know that m is equal to y2 minus y1 divided by x2 minus x1. So if in a certain situation we have 0 on top and a certain number, m is equal to 0. However, we don't need a situation where the denominator is 0. If the denominator is 0, for example, we have maybe a number 8 on top and 0 like that, this solution here is going to be undefined and we don't want to work with that. dy dx is going to be equal to 3x to the power 2 minus, that should be 6. 3 multiplied by 2 gives us a 6x to the power 2, and then we have another minus 6x minus 12. Then we know that at a stationary point, dy dx is going to be equal to 0. So we're going to set this expression that we have, the gradient function, we're going to equate it to 0, and then we're going to find its solution. Notice that we've got 6 as a factor, so we can divide each and every term by 6, and then this is going to simplify our work. If we divide this by 6, by 6, and by 6, and by 6, what we're going to have as a result is x squared minus x minus 2, and this is going to be equal to 0. Now we're going to work this out just like a quadratic, so we need to find the product, sum, and factors. Let's do that quickly. The products are -2. The product is -2. The sum is equal to -1. Our factors are going to be -2 and 1. So what we're working with now is if we replace this -x by the factors there multiplied by x, we're going to be working with x squared minus 2x plus x minus 2 equal to 0. Now we're going to group these terms, and by grouping we're going to factorize them, which means we're going to have, for these first two, x is common. If we factor out x, for the x squared we'll be left with x, while for the 2x we'll be left with a 2, and then for this other side they just have 1 in common, and this will be equal to 0. Next, we factor out x minus 2. When we do that, we're left with, this should be positive, x plus 1. Now here, in case you've never noticed what happens, really, we're going to divide by one of these. So we can say x minus 2 on both sides. We divide by x minus 2. Notice here we cancel, and therefore this x plus 1 will be equal to 0. Now instead of doing all that, we just accept it in mathematics usually that we're going to equate each of these expressions to the 0. So for the first one, x minus 2 is equal to 0. We have x is equal to 2. While for the other one, we can say or x plus 1 is equal to 0, and x in this case is going to be negative 1. So what does this indicate? When we go to our earlier sketch here, it tells us that one of these points here is going to lie on the x coordinate minus 1, while the other one, the x coordinate 2. To just prove this, what you would do is get these x values and then plug in them into dy dx. You should get an answer of 0. Now, what is left? Remember, the question is asking us to find the coordinates of the stationary points. So we found the x coordinates for these stationary points. We need the y coordinates. Not a very big deal, right? Since we have the x coordinate and then we have the function that relates x and y, we can find the values of y for this curve, where we expect these points to have a gradient of 0. So when x is equal to 2, we expect that our function is going to be 2 to the 3 minus 3 x squared minus 12 x, which is 2, plus 4. Not so? Yes. And then we simplify this. Y is equal to 2 multiplied by 8 minus 3 multiplied by 4 minus 24 plus 4. So y is going to be equal to 16 minus 12 minus 20. I've simplified this part, and when we work with this, okay, that's negative 32. Negative 32 plus 16 gives us negative 16. So this is the value of y. Next, we're going to do the same. This time, we're calculating the value of y when x is equal to negative 1. Our function is there, so y is equal to 2 negative 1 to the power 3 minus 3 negative 1 to the power 2 minus 12 multiplied by negative 1 plus 4. We can simplify this. Y is equal to negative 2 there. Here we're going to have negative 3. Notice negative 1 to the power 2, negative 1 raised to the 2 is 1. 1 multiplied by negative 3 is negative 3. And then negative 12 multiplied by negative 1 gives us a positive 12. Then we have a plus 4. This is 16 16 minus 5 is going to give us y is equal to 11. Okay, so we have our coordinates now. So our coordinates are 2, -16 and -1, 11. You might be thinking, well, calculus is all about all these things. Well, I would like to end this video on a very good note. Let's try seeing our solution. Right, so here on screen we have the graph of y is equal to 2x to the power 3 minus 3x squared minus 12x plus 4. This is the function we were working with. And remember how I kind of sketched it? It looked something like this, right? Yes, now we're going to go to the point -1 and see the number that's there. If you look with me here, this number is approximately 11. You see that? 10.99, which are the values that we actually were working with. If we check here, it's also 2, -16. So these are actually the values that we were working with. If we examine, if I can get it to 16, but yeah, it's a bit tricky to get that accuracy. So using calculus, we can do a couple of things like this. You might hear terms like maximum, minimum. This point here is the minimum. In calculus, when you go into further discussions about it, you can find all those things. Notice how we solved and used assumptions that we know to come up with the answers for this solution, even without the graph. That's the power of calculus.